Welcome to Ask and Learn.
Hello students. In this question, a linear molecule of hexatriene has been given and the carbon-carbon double bond length and the carbon-carbon single bond length has been given. We have to find out the wavelength that corresponding to the transition from the ground state to the first excited state. So the n value corresponding to the ground state is 0 and the first excited state is the 1. So coming to the hexatriene, so hexatriene consists of 6 carbon chain. So here there is a 3 double bond and 2 single carbon-carbon bond present, and hence the total length of the molecule will be equal to 3 into carbon-carbon double bond length plus 2 into carbon-carbon single bond length. So we are going to substitute the value, that is 3 into 135 plus 2 into 154. On solving this, it will be equal to 713 picometer. So converting this into meters, 713 into 10 to the power minus 12 meter. So which is equal to 7.13 into 10 to the power minus 10 meter. So using this, we are going to find out the energy corresponding to individual level, which is given by the formula E of n is given by n square into h square divided by 8m into L square. So we know that E of 0 will be equal to 0 because n square value is equal to 0. E of 1 will be equal to 1 into 1 square, and h is the Planck's constant 6.626 into 10 to the power minus 34 joules second square divided by 8 into m is the mass of the electron, 9.1 into 10 to the power minus 31 kg, and L is the length of the molecule, which is given by 7.13 into 10 to the power minus 10 square. On solving this, we can find out the E of first energy level will be equal to 1.186 into 10 to the power minus 19 joule. Now we are going to calculate the del E value, which is given by E1 minus E0. So this value is equal to 0 and hence it is equal to E1, and this value will be equal to 1.186 into 10 to the power minus 19 joule. We know that E is equal to h into nu. We know that nu is equal to c by lambda. On rearranging this, lambda is equal to hc divided by E. Substituting the values, the value of h is 6.626 into 10 to the power minus 34 and c is 3 into 10 to the power 8 divided by E value is the energy 1.186 into 10 to the power minus 19 joule. On solving this, we can find out the lambda corresponding to this, that is the wavelength corresponding to this is 16.761 into 10 to the power minus 7 meter. So converting this into nanometer, it is given by 1676.1 into 10 to the power minus 9 meter. So this will be equal to 1676.1 nanometer. So this is the answer to the first part of the question. In the second part of the question, we have to compare the wavelength. The wavelength corresponding to the transmission given in the question is 240 nanometer, which is determined by the experimental method. We need to compare this with the calculated value, but the calculated value here is 1676.1 nanometer. So here the lambda of the calculated value is very much greater than the lambda of the experimental value. So the answer to the question is the calculated value is larger than the experimental value. Coming to the third part of the question, we have to suggest the way we measuring the lambda by adding the bond length is correct or wrong. So as the calculated value is larger than the exact or the experimental value, this would suggest that finding the length of the pi electron system by adding the single bonds and double bonds is not the accurate method, because the pi system have shorter length compared to the adding them. Hope you find this video useful. Thank you.